This class, let's learn a special one, recurrence sequence. So what does recurrence or recursion mean? It's all about iteration. So in computer science, iteration, this idea is used a lot. It's more like a flow chart. So from program 1 to program 2 to program 3, and then you need to check if the value is good in program 3. If it's not, you just make it to go back to program 1 and to go through this channel again, and then to check if it's good. If it's not, still let's just do it again. So this is called iteration. So basically you just repeat yourself until this satisfies your condition. So it is like a loop. So in sequence, how does it get a loop? So it's more like I have given you a expression of an plus 1 equals an plus 1 over 1. So this is called a iteration. Let me just give you the value of a1 equals 1. So we can try to find the value of a2. Well, based on the formula, every term satisfies this. So a2 equals a1 plus 1 over 1, which is 1/2. And if you want to find a3, so it's 1 over a2 plus 1, which is 1/2 plus 1, so it's 2 over 3. This is called iteration. You have to find each term's value based on the term before. So in order to find the value of 800, you have to go through this channel 99 times in order to find it. So this is called iteration. You have to do it repeatedly from the same expression. In math, recurrence shows up quite often. So what is it exactly? Earlier for an arithmetic sequence, a1, a2, a3, an. So an is related to a1, and most of our expressions, an equals a1 plus n minus 1 times common difference. But if you treat the arithmetic sequence as recurrence sequence, so an, the correlation between an and an plus minus 1 is a common difference. So this kind of expression is called recurrence sequence. An is directly linked to the term before, not the very first term. So let's just look at a simple example again. So a1 is 2 and an plus 1 equals an plus 1. So we can try to find the value of a2. So a2 is, if substitute the value of n equals 1 here. So a1 plus 1 is a2 equals a1 plus 1, which is 3 to the power of 1/2. And if you are trying to find the value of a3, so it's a2 plus 1 to the power of 1/2, which is 3 to the power of 1/2 plus 1 to the power of 1/2. So this is called recurrence sequence. And for this expression, if you're trying to find a 100 terms, you have to substitute the value back to this equation for 99 times. That might be a bit of complicated in hand, but for computers, it's definitely not hard. It just needs to go through the same algorithm again and again to find the value of 100. But when we're thinking of it, so what is the value of, let's say, a 10,000 or 1 million or a billion or to infinity? What is the value when n approaches infinity? So here's the thought. If it has a infinity value, so a to the infinity must equal to the infinity minus 1, which means an equals an plus 1. Because basically, these are all infinities. They don't have any huge difference. And literally, they're still infinity. So we assume their infinity value is the same. So let's make it a, big A, capital A. So it's capital A equals a plus 1 to the power of 1/2. So a squared equals a plus 1. A squared minus a minus 1 is 0. So we can solve the value of a So as certain is infinity value. And this is how we use the recurrence sequence. And let's try another one. So this will test your observation ability. So given you an equals cosine pi times n over 2, and I need you to find the S100, the sum of the first 100 terms. How do you do that? Well, firstly, don't just panic. Just list out some of the few terms. And let's just try A1. So A1 is 1, the value of n is 1. A1 is cosine pi over 2. So here's a graph of cosine, which is 0. So A2 is cosine pi, which is -1. And A3 is cosine pi over 2 times 3, so it's here, which is 0 again. And for A4 equals cosine 2 pi, which is 1. Until now, I have listed the former 4 terms, but it's not enough. Because what we're trying to looking forward, what we're trying to look for is the sum of the first 100 terms. So it's still far from our result, but no worries, let's just try to list a bit more. A5 is cosine 5 over 2 pi, so which is, we can try to do the graph again. Here is 2 pi and here is 5 over 2 pi, which is 0. And A6 is cosine 3 pi, which is -1. And for A7 and A8, which independently 0 and 1 as well. And so we can tell they seem to have a fixed pattern here. If you treat every 4 items as a group, so this group itself is recurrent. So I can tell every 4 numbers of them is a group, and the sum of the 4 terms, A1 plus A2 plus A3 plus A4, is 0. And now we can guess how many groups, how many sets are there in the first 100 terms. So exactly there are 25 groups. So it's 25 times 0, which is 0. So this is how we solve this kind of recurrence problem. We list all the numbers as far as we can, and we're trying to observe something from the group. And then the results just come out naturally. And just need to remember, our exams would never test you as a strong labor. We don't need you to do over 100 calculations. That is not realistic. So if the question needs you to solve the first 100 or 50 or 200 or 1000 terms, the paper is definitely trying to test your observation. It's not about hard calculation. It's never not. So you should just know the trick. And recurrence relations aren't tested heavily, but you should recognize them. They describe how a term relates to the previous or next term. And when you see one, just break it down step by step, and it will be totally fine. Okay, so hope you can learn something from this class, and let's see you next time. Bye.